4.4 Polynomial equations, inequalities, applications, and model. In this video, we'll just focus on polynomial equations and inequalities. To solve any quadratic equation, we can use the quadratic formula. There are similar but very complicated formulas that can be used to solve third and fourth degree polynomial equations. So we do here, so we're going to solve some third and fourth degree, but we're not going to use very complicated. What we're going to do is we're going to use elementary methods to solve some higher degree polynomial equations. That's all we're going to do. So we'll show you some tricks of how to solve some third and fourth degree polynomial equations. So let's go through an example. Solve x cubed plus 3x squared minus 4x minus 12 equals 0. And then we're going to use our answer there to help graph this. And then we're going to use that to solve some inequalities. And actually, let me write down the inequality we're going to solve, which is this guy. Let's solve this greater than 0. Okay, so let's start out just by solving this problem here. X cubed plus 3x squared minus 4x minus 12 equals 0. It is an x cubed, so I can't just use a quadratic formula. But I could factor it. And a lot of times we want to do when we have, anytime you have more than a trinomial, you have, like right here we have 4 terms, you want to factor by grouping. So we're going to group the last two and the first two. In the first two here, you can factor what they have in common, which is an x squared. So let's be x squared. Remember when you factor out, you just divide by it. So I took out 2 x's, so there's the 1 left. I took out 2 x's, so there's only the 3 left. You always bring down the middle term when you factor by grouping. So whatever that middle term happens to be, you bring it down. These two have a 4 in common. So I go divide them both by 4. 4x divided by 4 is x. 12 divided by 4 is 3. Now, and actually mess that up real quick. It's negative 12 divided by negative 4. Remember, you're dividing by this guy. So that becomes a positive 3. And now these match. Don't forget the size so equals 0. And now that these match, you could factor those out. And you get x plus 3, x squared minus 4 equals 0. Now, two things we go here, we could factor this some more. It is the difference of 2 squares. So we actually could factor it again. So you get x plus 3, x minus 2, x plus 2. Or you could just use right here and split and solve. Either way, you get the same answer. So it doesn't really matter. Anyway, let's split and solve here. X is going to equal, right? So you set each one of these equal to 0. Using the 0 product property. And you get negative 3, 2, and negative 2. So there we go. And again, if you would have solved it from here, you would have got x squared minus 4 equals 0, which would have been x squared equals 4, which would have been plus and minus 2. So you get the same answer either way. Let me erase that. I need the space. Anyway, so that's our answer for A. Solved it, right? I factored by grouping, factored it down. I factored it to the very end, but you want, you could split it from here, and I got my 3 answers. As we know, we should have 3 answers because it is x cubed. Next, I want me to graph this. Just graph the function. So this we could do using all the stuff we learned in the previous sections. So we're just going to do a sketch. My x-intercepts are negative 3, negative 2, and 2. So like that, those are my x-intercepts. Now notice there's a positive x cubed, so we're going to start on the top right, and then we're just going to go through all of these. None of these have a multiplicity higher than 1, right? There's no balancing on this one, so you're just going to go through all of them. So it looks something like this. Top right, because again, it's positive. And we're just going to go through it, and go through it. So our graph looks kind of like that. If I ever wanted to, I could have found the y-intercept by plugging in 0, but this is my graph. This is a sketch. So we have that. Now let's solve C. Right? C wanted to solve this right here. I had to edit it myself. So we want to solve this guy greater than 0. Now how do we solve this? Well, let's rewrite it as the factored form. So I want x plus 3. Actually, I don't even need to do that. What am I doing? I don't need to do that. I want to solve where this guy is greater than 0. I have the graph for this guy right here. Right? We already have the graph. We made it a second ago. So where is this greater than 0? Remember, when it's greater than 0, it's above the x-axis. So that would be right here and right here. Right? This is where the graph is above 0. So my solution will be from negative 3 to negative 2, union 2 to infinity. So that's where this graph is above 0, right? So how do we do that? Well, I got the original graph and I factored it, and I got my x-intercepts also, or my zeros. I plotted those x-intercepts, and then I just used all the information on before, which is this is a positive x cubed, positively in coefficients, so you start on the top right. All the multiplicities are 1 in this case, so you just go through them. So there's your graph. And then it says I want a greater than 0. Greater than 0 over here above the x-axis, right? Here's my x-axis. So we're above it, here and here. So that's one way to solve these things. Another more common way to do it is using stuff that's already in quadratic form. So this one was in quadratic form. See how it, like 4 terms, not quadratic form. Quadratic form is like the more way of writing out a quadratic. So you're probably more used to it. We're all more used to it when it looks like this. I'm not sure why I tried to square that thing. There we go. Right, that's quadratic form. But the thing here is that it doesn't have to be x squared and x. The general rule is as long as this middle term is half of the first term, as in the power, then it's in quadratic form. So this counts as, so this is technically the quadratic form, the proper quadratic form. Like that, right? So the middle term is, the first term is double the middle term as the power. So something like here, x to the 6 minus x cubed. See how this first term is twice power of the second middle term? This is in quadratic form. I can just factor like normal. You find two things that multiply to get negative 6. So it'll be negative 3 and 2. So you get x cubed minus 3 and x cubed plus 2. That's quadratic form, right? When you factor this, you generally get something where it's x to the n plus or minus something, and x to the n plus or minus something. Now this one actually has a number in front, which makes it a little more difficult, and we'll do one of those later. But as long as the middle term is half of the first term, like power-wise, then it's in quadratic form, and you could factor it like a normal problem. And if you want to double check, remember if you're not sure, you can always double check, but you can always multiply out and see if you got the right answer. You get x to the 6 minus 3x cubed plus 2x cubed minus 6 as middle terms, x to the 6 minus x cubed minus 6. So, right, I got what I want. So it does work when it's quadratic form. This next one, notice how the middle term is not half, it's not half the first term. The first term is to the 5th, half of that would be 2.5. This is not in quadratic form. So we can't factor. Now let's look at the last one here. This one is in quadratic form, right? X to the 5th is half of x to the 10th. So I can just factor this like normal. I find two things that multiply to get negative 6, which we did already, so it's negative 3 and 2. And then you just go, okay, it's always the middle term right here. X minus 3, middle term plus 2. And that's how you factor stuff in quadratic form. So let's solve a problem doing quadratic form. So here we go, x to the 4th minus 6x squared minus 40 equals 0. So let's solve that. Now keep in mind, right, this is a x to the 4th, so we should have 4 answers. And we should actually, at the end we should have 4 answers. So let's solve it. Again, this is half of that, so I can just factor like normal. Just looking at, all I'm going to look at is negative 40 and find two things that multiply to get 40, but add to get negative 6. Now keep on, it's a negative 40, so I could probably do negative 10 and 4. I think that would work. And that does, right? Negative 10 plus 4. Negative 10 times 4 is negative 40, but when you add them up, you get negative 6. So all we're going to do is get the middle term, x squared minus 10, middle term, x squared plus 4. Equals 0. Now last time I factored some more. Now you really can't do that here. This is the prime number. This you technically could, but it won't be a nice number. So we're just gonna, from here we're just not gonna factor it. We're gonna solve it. We're gonna use the zero product property and split each one. Set each one equal to 0. So let's do this one first. I'm gonna add 10 on both sides. So I get x squared equals 10. Let's square root both sides. You get x equals plus and minus for add 10. Nothing else I could do there. Over here, subtract 4. X squared equals negative 4. Square root of both sides. I get x equals plus and minus 2i. Right, take out the i, the radical is an I, and then square root of 4 is 2. So look at, we get 4 answers. Plus minus here, plus minus there. Next question. Graph P and use the graph to solve the inequalities, this and that. Okay, so let's talk about how to graph this, because there's some imaginary numbers and we'll talk about how that affects it. So this is P is the same. So we want to graph this. Okay, so here's the thing. When you graph this is a real number line, so we do not include the imaginary numbers. So they're just not part of our graph. All we have to graph is plus or minus rad 10. Now let's not go crazy about this. Rad 10 is a little bit more than 3. But honestly, all I care about is this. Rad 10's over here, and negative rad 10's over here. Right? One's on the positive side, one's on the negative side. If you want to be more correct about it, it's around 3. Because I know 3 squared is 9, and 4 squared is 16, so it's a little closer to 3 squared. So, let's graph it, right? Again, it's a positive x to the 4th, so that means we're going to start on the top right, and then we're just going to go, all my multiplicity is 1, so I'm just going to go through both of them one time. So, start top right, go through. Again, we're just doing a sketch. Don't need the y-intercept or anything. So, there we go. Let's answer, this question first. X to the 4th minus 6x squared minus 40 is greater than or equal to 0. Now again, I have the graph already. So where is it greater than or equal to 0? Right here is where it's greater than 0. So where it's above the x-axis. So that'd be from negative infinity to negative 10. Negative rad 10 union rad 10 to infinity. Right, the numbers suck, but that's how you solve it. Like, it has those things in it. If I wanted to solve the other one, I'll just leave it right here. Where it's less than 0, or it's less than 0 where it's below the x-axis, so it'll be right here. So where it's less than 0. So my answer that would just be from negative rad 10 to rad 10. This one should be a bracket. I didn't notice that it was an equal to on this one. So it should be brackets right here and here. So there we go. Let's do some more. So let's solve. We're going to solve these analytically. So we're just going to solve more of these. Now here, this first one, it's in quadratic form, but it is not an easy one. Well, not this easier version of it. Right? There's a number in front, so I can't just factor by the last term. What I do here is the exact same thing I always do. If there's a number in front, I just multiply the first term and last term, and I get negative 36 x to the 4th. Honestly, if you factor this way, nothing changes. You just multiply the first term and last term. Okay, I get this. Find the combination. Two things I multiply, I get negative 36, but add to get 5. So we got, let's see, we could do what? 9 and 4. I think it is 9 and 4. So when you split up, one has to be negative, one has to be positive. Let's figure out which one it is. Right, when you split it up, keep in mind, you got to split it in half equally. So x to the 4th becomes x squared for both of them. So that's how you break it up. And then again, I needed two things multiply to get negative 36, but add to get negative 5. So negative 9x squared plus 4x will get me negative 5x squared. Again, if you've seen this before, all I do now is substitute this in for that negative 5. So the 4x squared, x to the 4th stays. The minus 9 in the back stays. The middle gets changed to this. Sorry, minus plus 4x squared. So I get something like that. Right? You change the middle with that. And now we factor by grouping. The first two have an x squared in common. Pull out an x squared. Remember, all you do is divide by it. So there was 4 x's, now there's 2. So 4x squared minus 9. You always bring down the middle sign. The back has nothing in common. They have nothing in common. So you always could factor out a 1 though. 4x squared minus 9. These match. So we get 4x squared minus 9. Those are gone. And what's left over? X squared plus 1. So I get that. So I factor this guy. So I factor this thing completely. As far as I can. Almost. Don't forget it's equal to 0. So I almost forgot about that. And when I said almost, I just noticed this. I can actually factor this some more if you want to. That's the difference of two squares. Right? This one's squared and that one's squared. I could factor that to be 2x minus 3. 2x plus 3. So I get that. Now I cannot factor x squared plus 1 because it's a positive. You can only do it when if both things are squared, you can only factor it when it's a negative. Anyway, now I want to solve it, so you just split each one up. We're going to get 2x minus 3 equals 0. 2x plus 3 equals 0. X squared plus 1 equals 0. Move it over, x equals 3 halves. X equals negative 3 halves. Over here we're going to get x squared equals negative 1. Square root both sides. And you get x equals plus and minus I. Square root of negative 1 is I. And there are 4 answers, right? We needed x to the 4th, we needed 4 answers, and we have 1, 2, 3, and 4. So that's A. I was just solving that. B. Solving another one. I'm running out of space here. Let's see how I could solve B. 2x cubed plus 12 equals 3x squared plus 8x. So first thing I'll do with this is set equal to 0, because that's how you solve any power that's bigger than x. Set equal to 0, so move stuff over. So minus 3x squared from both sides, and minus 8x from both sides. You want to put it in order, so 2x squared minus 3x squared minus 8x plus 12 equals 0. You always want to go in descending order. So I subtract this from both sides, subtract that from both sides. These will cancel out, and they'll be moved over to this side. And now we just factor by grouping. These have an x squared in common. So you're left with 2x minus 3. Always bring down the middle sign. These have a 4 in common. I can divide them both by 4. And now remember, when you factor out, you divide. So negative 8x divided by negative 4 is 2x. And here's the important one. Positive 12 divided by negative 4 becomes a negative 3. Haley's match. So you get 2x minus 3 times x squared minus 4 equals 0. And if you want, you can actually factor this a little bit more. It is the difference of two squares. So you get 2x minus 3 times x minus 2, x plus 2 equals 0. And there we go. My answers are going to be split and solve. X equals 3 halves, x equals 2, x equals negative 2. Those are my three answers, right? X to the third, got all three answers. So, right, a big way of factoring today is this factor by grouping. Put them all on one side, factor by grouping. If you put it all on one side, you only have three things. Check if it's in quadratic form, which means the middle term is half of the first term in power-wise. Like the middle degree is half of the first degree. Probably the best way I should be saying that. And then you can just factor like normal. Okay, let's see what's that. X to the fourth. Show that 2 is a real solution to this, and then find all solutions to the equation. So it's a little callback to the last lesson. They're telling us, hey, 2 is a real solution. I know what one answer is. So remember when they give you an answer, how to use that? We use synthetic division. So when they tell us that p of x, a solution is this guy. I don't need this. Since I know that 2 is a solution, I could use synthetic division. Right? And when it's a solution, I just put it there. Write down the coefficients. Last one's my remainder. It should be 0 if it's a solution. It should be 0. Bring the first one down. Multiply across. You multiply these two together. So I get 2. We add down. Oh, people always complicate that. It's just adding down. And then we just repeat the process. Multiply these together. So 10. Add down. Negative 11 plus 10 is negative 1. Multiply these two together. Negative 2. Add down. I get 0. So it is a solution. I did get a 0. Now remember what happens here? You always go down a power. So that was x cubed. So this makes this x squared. Then just go in order. Plus 5x minus 1. Now we do want to solve this. So set equal to 0. And solve it. That is not factorable. So it's a quadratic. So remember, one way that always works if it's a quadratic is a quadratic formula. So we'll do x equals negative b plus or minus b squared minus 4ac all over 2a. Keep in mind our a here is a coefficient of each thing. So a is a coefficient of this guy, which is 1. B is a coefficient of this guy, which is 5. And c is a coefficient of this guy, which is negative 1. Let's sub it all in. So 5 goes here, 5 squared minus 4 times 1 times negative 1. And that's a 1. So I get negative 5 plus or minus. Look what happens in here. I get 5 squared, which is 25. But I have minus 4 times a minus 1, so it actually becomes positive 4. So I get 29 in there over 2. And that's pretty much it. I really can't do anything else with that. So I get negative 5 plus or minus rad 29 over 2. So those are my three answers. I got 2 and I got these 2. Alright, so 3 answers. B, support the result of part A graphically. So they want me to graph this. So I guess you can use your calculator if you want to here. If you want to do it by hand, you're going to have to estimate what this guy is. So it's negative 5. Let's see, let's look at it this way. Negative 5 plus rad 29 over 2. And then negative 5 minus rad 29 over 2. So again, you feel free to use a calculator to get a decimal. If I was going to estimate this, rad 29, it's between 5 and 6, right? 6 squared is 36, 5 squared is 25. So a little closer to 5. So it's a little bit more than 5. So this divided by this, negative 5 plus 5 over 2, for like 5.1. So I'm going to get like almost 0-ish. And then this one, you get negative 5 minus, let's say 5. So negative 10 over 2 is like a negative 5. So if I was going, here's my x, here's 2. I have essentially 0. Let's say this is approximate that's 5. It's a little bit more than 5, but whatever. You get 0 divided by 2, so it's about 0. And then over here we would get 5, and we get negative 10, all this together divided by 2, so negative 5-ish. So my graph will look kind of like that. It is a positive x cubed, so we start in the top right. And the multiplicity of everything is 1 again. There's nothing that has a power more than 1. Multiplicity is all 1, so you just go through them all. So it looks something like that. That'd be your graph. Again, feel free to use your calculator to plug it in and see if it works. It's a little nicer. That's what actually we're going to do the next one here. Consider this graph. Use a graphic calculator to solve p of x equals 0, that and that. So we'll need a calculator. So here I brought in my calculator, and then to do this, we're just going to go to y equals. We're going to type in what they want to graph. 2.45 x cubed. Now cubed, I don't have a cube button, so you can put power cubed minus 3.14 x squared minus 6.99 x. Did it freeze on me? What's going on? It does that sometimes. There we go, 99x plus 2.58. Okay, so there's my graph. We're gonna hit zoom 6. I'm gonna go standard graph, so it looks like. And I get something like that. Now what do they want me to find? The zeros? Okay, so remember, we talked about how to find the zeros before. We're gonna go second, calculate, and then find the 0. So let's like find the minimax. So let's far left. So I want to find the 0. So all I'm gonna do is get kind of close to it and go a little bit left of it. So a little bit left, hit enter. Then you're gonna go back to it. Now hit it. Then wants to right bound, so go a little bit right of it. Hit enter. It says guess, and you hit enter. And we get negative 1.3. So if I was doing this, whoops, let's do it in black. Right, here's my x. Negative 1.3. Remember, the general idea of how to do how you're doing your calculator is you're going to go low left of your answer, that's my answer, make that left bound, then low right of your answer, and make that a right bound. Then we're going to guess. So I got 1, I got to find the other 2. So second calculate, go back to 0. I have that one already, so I'm going to go behind the next one, around there. So again, you can't just like go on, it's not going to work, you got to use the calculator. So go low left of your answer, so I'm low left of my answer. Right, and then go back to it and just hit a little right. Hit right a couple times, now you're a little right of your answer. And then hit enter. And I get 0.333. So around there. Then I need to find my last one. So let's do it one more time. Find the 0. Right, you want to get to where your answer is. Now remember what's like left and right kind of changes depending on like up or it's like above and below kind of changes. It's all about left and right. So get to where your answer is around there. Now hit left a couple times. Hit enter, that's your left bound. Now go back to it. Hit right a couple times so you get a right bound. Now it's in search between those two and you hit guess, and it finds 2.316. Like that. And I could say normally you say, oh, it's positive, starts on top right, you go through them all, but you actually have a picture, so you just use a picture also. Something like that, right? Ish. That goes, I mean, it's not the best graph, but that's an idea. So that's how so we solved it. So we did that, p of x equals 0. We got those x-intercepts. Negative 1.3, 0.333, and 2.316. Now the next one, they want to find when is this thing greater than 0? Alright, so I want to solve that. Well, look at our graph. When is it greater than 0? Looks like it's greater than 0 right here and right here. That's where it's above the x-axis. So my answer is going to be from negative 1.3 to 0.333 union 2.316 to infinity. So that's how you answer it. And if I wanted the less than 1, I'll just be the other side. It would be from here to there and from there to there. But there we go. Okay, last one, I believe. So we're going to solve a couple problems here. Now, notice again, these are the same questions. This one's inequality. So I'm just going to solve this one and then use the graph of this one to solve this one. That's all we're going to do. So solve the inequality. Now to do this, Oh, I would want to factor out, but these do not match. So instead we get distribute. So I'm going to get 2x squared minus 2 plus 4x squared minus 2x equals 0. Add up like terms. 6x squared minus 2x minus 2 equals 0. Now it's just a normal problem, like normal quadratic problem. I can divide everything by 2 actually if I make your life a little easier. So I get 3x squared minus x minus 1 equals 0. Again, you can solve the same way you want. Quadratic formula works. I believe this does not factor. So quadratic formula it is. Since it doesn't factor, this will be my a, this will be my b, which is -1, this will be my c, which is -1. Quadratic formula, x equals -b, so -1 plus or minus square root of -1 squared minus 4 times a times c, which is -1, all over 2 times a, which is 3, sorry. Like that. This becomes a 1, -1 squared is 1, -4 times 3 is 12, -12 but times another negative, so positive 12. So I just get this. Oops, sorry. Positive 1 plus or minus rad 13 over 6. So there I go. Now again, so there's my answer. That's part A done. Got 2 answers, that's all I needed, x squared, done. B, they want us to solve the inequality version of this, so I need to graph it. Now how do I graph this thing? Again, it's probably easiest if you, honestly it doesn't even matter. It doesn't, just go, we have one side is 1 plus rad 13 over 6. Again, if you want to put in your calculator decimal, it's fine. But this side is definitely going to be bigger than 1 minus rad 13 over 6, so I'm going to put it over here. 1 minus rad 13 over 6. Right, because 1 minus rad 13 will be a negative. Rad 13 is a little bit like between 3 and 4. 3 squared is 9, 4 squared is 16. So it's between those two numbers. And then you look at your graph, it is a positive x squared. So it's going to open up. Something to that effect. I want where you're less than it. So less than would be right here in between these two is where you're below the x-axis. So my answer is going to be from this guy to that guy. And there you go. That's the answer, and that's the lesson.